Hypothesis testing with two samples. Testing the difference between means for dependent samples using a p-value instead of a rejection region. For this particular problem, it will be best if we use technology. A food manufacturer claims that eating its new cereal as part of a daily diet lowers total blood cholesterol levels. The table shows the total blood cholesterol levels in milligrams per deciliter of blood of 7 patients before eating the cereal and 1 year of eating the cereal as part of their diets. Use technology to test the mean difference. Assume the samples are random and dependent and the population is normally distributed. At alpha equals 0.05, can you conclude that the new cereal lowers total blood cholesterol levels? Well, the first thing that we need to start out with is that we need to identify the claim, and then we need to identify the null and alternative hypotheses. So the claim is simply what's listed. The manufacturer claims that eating its new cereal lowers total blood cholesterol levels. So we write that as our claim. That means that our mean of the differences, mu sub d, is going to be equal to the value before minus the value after. And if the cholesterol levels are being lowered, that means that this must be greater than 0 because the before value will be larger than the after value. So this is going to be our claim, and this is also going to be our alternative hypotheses, since this is not a statement of equality, which means that we can write the null hypothesis, h sub 0, as the fact that the mean of the differences will be less than or equal to 0, and we can write our alternative hypothesis as the mean of the differences will be greater than 0. And as I stated, this will be the claim. The next thing that we want to do for this is go ahead and calculate the test statistic, which will be t. And once again, I had mentioned using StatCrunch at the beginning of this. For both t and the p-value, we'll use StatCrunch. So you want to go ahead and left click this icon, which will copy the table into StatCrunch. You'll have 3 choices: open in StatCrunch, copy to clipboard, or open in Excel. You want to open in StatCrunch, and that will open the table in StatCrunch, and it will look exactly like this. And so then we are going to do an analysis. We'll left click stat, scroll down to t-stats, and we will come to where it says paired. Left click paired. Now notice that for this one, we need to go ahead and put the columns in their proper place. Sample 1 will be in the first column labeled before. Sample 2 will be in the second column labeled after. We do not need to worry about where or group by. We can save the differences so that we can look at that. And then we need to go ahead and determine how to set this up based upon what we originally had written for our null hypothesis and our alternative hypothesis. So therefore, we'll go ahead and write the null as being less than or equal to 0, but since StatCrunch automatically defaults the null to just an equal, we have to adjust this one. And since we stated that the alternative hypothesis was greater than 0, we'll go ahead and left click that, and then we will just go ahead and left click compute, and you'll notice that it gives you your t-stat, which in this case is going to be rounded to 3 decimal places, 1.487. So we'll write that down. And then we also need the p-value. The p-value is also indicated in the table, and we'll look at that. And the p-value is right here. And that's going to be 0.0938, and we will round that to 4 decimal places. And now what we need to do is decide what our conclusion is. So in this case, since the p-value is greater than our alpha, which was indicated as 0.05, we will fail to reject the null hypothesis. So, since the p-value is greater than our significance level, of 0.05, we will fail to reject the null hypothesis, and therefore we can conclude that there is not sufficient evidence to support the claim that the new cereal lowers total blood cholesterol levels.